In every profession, one must be aware of their responsibilities. And precisely because of this, in moments of tension where you feel pressured, stop to think about the consequences of your decisions. Doctors, teachers, and especially engineers are continuously learning. During my engineering degree, there was one subject that particularly marked me. It was the history of aviation and professional ethics or something like that. I think that's what it was called. But not because the syllabus was very interesting, which it really was, but because I believe that subject made me a better professional. I believe it was more due to Professor Ruben da Pica than the subject. He would make us reflect on controversial historical points. For example, were the atomic bombs dropped in World War II justified? At first, there were two clear opinions in the class, those who said no and those who said yes. But the interesting thing was to see how he made both those who thought one thing and those who thought the other doubt. In reality, giving an opinion on a past event is easy when we have already seen the outcome. The complicated part is being given the information available at that time and making the decision then. Well, get ready, because in this video we are going to talk about the biggest negligence in the history of aerospace engineering, the Boeing 737 MAX. The content in this video is highly intense. That's why we ask you to watch the entire video to fully understand what happened. Above all, share your opinion in the comments. This video is crucial as it explores interpersonal relationships and we value your perspective on the topic. As always, you have all the documentation in the description below. When we see an airplane, we focus on the aircraft itself, not the interpersonal relationships of the people involved. And how do their interests and goals influence when working on the design of the aircraft? People always perform their work based on their surrounding interests. It could be to spend a small budget, do the job as quickly as possible, or anything else of the sort. The problem is when those interests interfere with the safety of the mission, putting future users and operators at risk. That's where it gets complicated. A clear example of this would be when the interest in getting an aircraft to fly as soon as possible becomes more important than the safety of the aircraft itself. This factor is often common in many accidents due to operational or maintenance issues, or perhaps on the part of the airline. What is not so common is to see the case where the manufacturer itself puts costs and manufacturing times ahead of safety. That a mechanic or a pilot commit negligence overlooking the potential danger is something that we could consider less serious than if the negligence is committed by the airline itself, as a company philosophy or as a way of operating. But the worst case, without a doubt, is when the manufacturer, in the design stage, commits negligence. These, if certified as potentially dangerous, can lead to significantly more accidents. We're talking about an entire fleet of airplanes distributed by hundreds of airlines in dozens of countries. Potentially could fail. It's simply unforgivable that something like this could happen, playing with the lives of hundreds of thousands of people. We want to show this not so good part of aeronautics and in general of the human being. Not only so that it doesn't happen again, but to keep in mind that situations like these will present themselves at any moment in our lives. Maybe not to this extent, but it's constant. In all jobs, there are moments when you will feel pressured to make decisions that may not be the right ones. Please, remember this video that day? Well, let's get on with it, with the negligence of the Boeing 737 MAX. For this, we need to understand the historical context in which it developed. Back in 2010, Airbus began developing the A320neo, the A320neo family, a new model of the A320 that would consume much less fuel. And therefore, many airlines that had been using the Boeing 737 began to place orders for A320neo aircraft to replace the old Boeing 737. Therefore, Boeing had to create a new plane to compete with the A320neo. As they didn't have time to build an aircraft from scratch, they decided to remodel the famous Boeing 737. An airplane designed in the 60s, which for decades has undergone changes that have resulted in new variants, more modern and economical, but all starting from the same airplane. As we have already explained on the channel, to improve engine efficiency, you need to increase the size of the fan. But this was not possible in the Boeing 737 MAX, as it is a low aircraft by itself, with the engines of the previous version already very close to the ground and therefore in this previous version of the Boeing 737. The bottom of the casing is flat so as not to hit the ground and respect safety margins. So, to increase the size of the engines, they had to push them forward and upward relative to the wing. After many trials, they realized this would also affect the plane's aerodynamics when flying at high angles of attack. the engine casing would generate lift in those cases. And therefore, they decided to incorporate a system that would detect when the plane was behaving unstably. And that through corrections in the trimming of the horizontal stabilizer with software, that lift that the engine casing was generating would be cancelled and the aircraft in that way would continue to be stable. Specifically, this system moves the entire plane of the horizontal stabilizer, known as the trim or compensator in Spanish. The aircraft's stability varies each flight based on passenger count, load, and weight distribution within the plane. And that's why the plane of the horizontal stabilizer can move completely and be put in the optimal orientation for each flight or at each moment of it. The maneuvering characteristics augmentation system, the system they were using at Boeing to make the aircraft stable. That's exactly what moves the entire angle of the horizontal stabilizer. When too much angle of attack is detected, the entire plane of the stabilizer moves to slightly lower the nose of the plane. And if after 10 seconds too much angle of attack is still detected, the elevator deflects a little more, and so after periods of 10 seconds. And this is where the trouble comes in. This system was incorporated without informing the airlines or pilots, as Boeing's idea was that the pilot would not notice the differences between this new model and its previous version. So that an old Boeing 737 pilot could fly a Boeing 737 MAX without needing to take another new course? So far, nothing seems odd, except for the part about not informing about the maneuvering characteristics augmentation system. Everything else made sense. However, the problem is that this system only took information from a single angle of attack meter. So if this failed and detected more angle of attack than the actual, the system would act and lower the nose of the plane even more in a completely uncontrollable way by the pilots and without them knowing what was happening. And this is literally what happened in the Lion Air 610 accident in October of 2019 in the Java Sea. Normally, in fact, the authority says that a system whose failure can generate a catastrophic situation cannot depend on a failure of a single component. It has to have redundancy no matter what, and the EMCAS didn't have it. But here the situation gets even more complicated, because in December of 2015, if we look at the timeline, a Boeing worker starts asking his superiors by email if the maneuvering characteristics augmentation system was only dependent on one angle of attack sensor, as this did not convince him. 6 months later, in June of 2016, another Boeing worker asked again by email about the issue. What happens if we have a failure in the angle of attack sensor or the mean aerodynamic chord number? He was told that if that happened, the maneuvering characteristics augmentation system would immediately shut down. Well, in both accidents, there were failures of the angle of attack sensor and the system did not shut down. Later, in 2016, a Boeing test pilot, while testing in a simulator, realized that the system was activating from time to time, causing the nose of the plane to go down. And he literally said, translating into English, "I don't think this is safe," and no one paid attention. 2 years later, the Lion Air Boeing 737 MAX crashed. And after that accident, everyone knew that the problem had been with the maneuvering characteristics augmentation system. To such an extent that even I, who am an ordinary person, simply went online to inform myself about the issue. I made a video explaining what happened in the Lion Air accident, explaining that the fault was with the maneuvering characteristics augmentation system and they took no action to fix it. Months later, the Ethiopian Airlines Boeing 458 miles AX crashed. Action was actually taken, but it was shameful. On November 6, 2018, after the first accident, airlines were informed about the maneuvering characteristics augmentation system for the first time. And it was explained that for high angles of attack, the aircraft could push the nose of the plane down. And that, in case this system failed, what happened in the Lion Air accident could occur. That's why a statement was issued informing that the pilots, in such case, should perform a runaway stabilizer procedure. Boeing 737 pilots are well trained for emergencies when examining the actions of the pilots in the recent accident of Ethiopian Airlines when they saw that the plane was pitching its nose down. We see that the first thing they did was to perform the runaway stabilizer procedure, and at first it seems to have worked. However, they re-energized the horizontal stabilizer and the EMCA was activated again, and from there, they couldn't save it again. We will make a video dedicated to these accidents, explaining this part in greater detail. The maneuvering characteristics augmentation system was not the sole factor in the accident. Many other factors must be considered. It's something completely unforgivable, but not only for Boeing but also for the FAA, which in this case was the authority certifying the aircraft. Boeing's engineers, of course, have the task of making the system safe, but the authorities are there to check that those systems are safe, and if they are not, to say so and not allow them to be certified. The Boeing 458 miles AX was certified, but the situation gets even more complicated. It turns out that in the United States, companies with a long history and complexity, like Boeing for example, the American Aeronautical Authority, the FAA, grants them a figure called Authorized Representatives from the English Authorized Representatives. These people are responsible for, on behalf of the FAA, certifying certain processes within the aircraft design. This streamlines work during certification by avoiding bureaucratic delays that require waiting for responses to continue the process. Basically, it means that there are engineers who work for Boeing who are granted certain authority functions. In other words, in some cases, those who certified the system's safety were not independent FAA workers from Boeing, but were Boeing's own workers, who in turn also answered to the FAA. Remember, they were rushing the design of the Boeing 458 miles, AX, to compete with the A320 NEO. They were surpassing Boeing and dominating the market. And that's why the Boeing engineers, the executives, and also the ARS had direct pressures from above to certify the safety of the system at the lowest possible cost and as soon as possible when clearly this system was not safe. The issue with ARs occurs not only in the United States but also in Europe. Is there this figure within companies that are responsible for certifying certain processes to expedite certification? The problem is not that. The problem is that these were not completely objective and were very influenced by their superiors. In 2016, an internal survey was conducted at Boeing to the ARS to see if there were or were not conflicts of interest when doing their job. And 39% claimed to work under pressure, and 29% claimed to be worried if they reported that the pressure was excessive. Here, without a doubt, is where the problem is. The authorized representatives figure must be able to work completely without pressure or fear so that their actions are legitimate and the best decision is made in tense moments. But the need to certify the plane as quickly as possible led to a pilot doing simulator trials in 2012. Again, he found himself in a situation like the accidents where the maneuvering characteristics augmentation system sent the nose of the plane down and the test pilot could not control the plane. At the end, he reported this as a catastrophic situation, but due to the aforementioned pressure, his superiors ignored him. On March 10, 2019, the Ethiopian flight crashed with 157 people on board. On March 11th, China banned the MAX from its airspace. The following day, Singapore, India, Turkey, South Korea, the European Union, Australia, and Malaysia followed suit. Meanwhile, the FAA stated that the aircraft remained safe. Until the next day, on March 13th, they retracted and ordered the immediate grounding of all Boeing 737 MAX. If you notice, it's tremendous. Because the FAA, who certified the aircraft's safety, refused to admit any wrongdoing under any circumstances. And that's why they were the last to acknowledge that the aircraft was not safe. Since then, they got to work to fix the situation of the aircraft. And 2 years later, throughout the year 2021, airworthiness was gradually granted again to Boeing. 458 miles AX throughout all countries. If you're interested, leave in the comments and we'll make a video explaining the changes that have been made to the plane. The final document on the Boeing 458 miles AX investigation contains very strong statements. Literally, there is talk of a culture of concealment on the part of Boeing or of a Boeing influence on the FAA, or paragraphs like, both Boeing and the FAA gambled with public safety after the Lion Air accident, resulting in the death of 157 people on the Ethiopian Airlines flight. Less than 5 months later. Okay, let's take a moment because it's very easy to criticize after knowing what happened with the accidents, right? Criticize the engineers who made the decisions? But you? Keep in mind that those engineers are probably very good people, with normal families just like any of us, and they are also very good engineers. I am very convinced that they really did not think under any circumstances that this would cause an accident. They would simply be thinking that the way of certifying it was a bit strange, but under no circumstances would they think that this would lead to accidents. But also, don't forget about all the pressure that was coming from the superiors who were telling them that it had to be certified as soon as possible. The Boeing 458 miles AX had to be completed to compete against Airbus. If someone at Boeing delayed signing the document because they doubted the plane's safety, that would be a significant concern. Everyone would point the finger at him, saying that he is the one to blame for the company not prospering. Really, put yourself in their position. It's not easy at all. In fact, I'm very convinced that both you and I would have probably acted the same way. We all like to feel different. It's something about being human that makes us feel special. When the reality is that we are all the same in the same situation, most of us would have probably acted the same way. And also, it's worth noting that very few engineers within Boeing acted outside the law. The Boeing 458 miles AX certification issue stemmed from exploiting legal loopholes. In the end, very few engineers faced consequences because their actions were not illegal. Some did, and they should be blamed, as that is unacceptable. In life, it's crucial to consider the potential consequences of your actions. And in pressure situations, analyze if there are interests that are blinding reality or if you are making the decision due to pressures from above. This really is something very complicated. In the case of engineers and maintenance managers, when repairs are made on aircraft, they have to sign once done as a confirmation that the aircraft is ready to fly again. If anyone who is watching this video has ever felt any kind of pressure in this regard, working in maintenance, please put it in the comments. Imagine a hypothetical case where you are a member of an airline's maintenance team and they tell you that next week such a plane has to leave because it has a very special mission, and you are in charge of signing the last document of all that the plane is correct to leave. Imagine that just the last day of all. You discover something a little strange in that repair that has been done, but something very small, because if of course you discover that the repair is poorly done. That the wing is broken, obviously you are not going to sign the document because you know it's broken, but suppose in the case that it's something very small, for example, that there is on a wing. 50 rivets. Well, 2 of those 50 rivets have been used from a slightly old design of rivet. Since there were none left in stock of the new ones, and placing the order would mean delaying the repair of the aircraft a lot. You discover that the day before everyone tells you that absolutely nothing is going to happen to the aircraft. You turn to the rule, which is the authority's statement, and begin reading. Imagine it says that in the repairs, all the rivets have to be there. Indeed, in your repair, all the rivets are there. The thing is, there are 2 that are from an old model. In addition to everyone telling you to sign and that nothing will happen, your superiors are also pressuring you to do so. If you already have the aircraft ready, why is the important mission coming tomorrow? What would you do in cold blood? Probably most of us would say we wouldn't sign the document, but really put yourself in the situation. With this video, you have been able to see all the psychology behind aeronautical projects. Because despite being machines designed based on science, they are people who designed them and the behavior of these before. Critical situations is very interesting. Subscribe if you're not, and see you soon in the next video.